Hi guys, it's Ms. Griffin. We're looking at Unit 11, Skill 5. So we're going to move away from the probability part of this unit and move into statistics. So we're going to start with our essential question. How do we describe distributions of data, and how do we use z-scores with normal distribution? So pause your video so you can write this essential question down. This is what we're going to answer as we go through these notes today. So we're going to look at different sample distributions. When we plot data, we can get a distribution. There's a variety of options for distributions, with some of them shown below. So looking at this first one, we're going to call this symmetric. And you can imagine that we are calling it symmetric because the one side looks like the other, right? Woo! This might be something like people's heights. We have very short people, we have medium-sized people, and then we have really tall people. Well, we have very few really tall people. Those are the guys on this end. We have very few really short people. Those are like the 4'10"ers. And then we've got these people in the middle that are your typical like 5'3" to 5'7" or 5'9", depending on who you're talking about here. So we've got low numbers on the side, low numbers on the side, and then quite a bit of the population here in the middle. So that's symmetric. Number 2 is bimodal. Ooh, spelled that wrong. Bimodal. Which means that we have like two different heights here going on. We've got this, and then we've got this. So an example of this would be something like the heights of people in a choir. So say we're talking girls over here, guys over here, you're going to have, again, very few short people, very few tall people, and then most of your population's here sitting in the middle at that average height. Another thing might be like the price of paperback books on Amazon under $30 versus hardcover books. So again, you have two like peaks here essentially. Number 3, we've got something called skewed right. This is one that comes up. Okay, so you got to know it. Notice this curve, tail to the right means skewed right. So something might look like housing costs. So you could have houses that are often about $100,000 in a particular area, and then you could have a few that are like $250,000 or more, right? So you have a lot that are in one range of numbers, and then you have very few in this upper range. The alternative to that would be this one, skewed left. So in this case, the tail goes left, therefore it's skewed left. So this might be something like retirement age. When you retire, you're probably not going to be 25 years old. We've got a few people that might retire at 25, but we've got a ton of people that are going to retire in their 60s. Okay, so retirement age. Example number 5 is a combination of 1 and 2. It's symmetric and bimodal. Symmetric and bimodal. So this might be something like peak restaurant hour. So a restaurant might get a lot of people during the lunch hour and during the dinner hour, but they're not going to have that many people in the in-between. Like that 3 o'clock, 4 o'clock time frame, not many people sitting in the restaurant, right? Number 6, last one. This one is called uniform. It's called uniform because it's pretty much all the same, right? So something like this might be like serial numbers, not cereal that you eat, but cereal like this. Numbers on randomly selected dollar bills, right? You might have some that are the number 1, 4, 5, 6, 7, 8, 9, and then you might have the same amount that are 1, 2, 4, 8, 9, 5, right? Who knows what the numbers actually are, but this is just one example where you're pretty much going to get the same number of serial numbers that are randomly selected on dollar bills. Okay, or another example is like the number that comes up on a die after a roll. So you could get the numbers 1 through 6 on that die when you roll it, and then you'll probably get the same number of 1s as you would get when you roll and you get 5s. Okay? So those are various distributions that you could have. Now there's one that we're going to talk about that's related to this whole standard deviation thing. Standard deviation shows how much variation, dispersion, spread, or scatter from the mean that exists. Remember that the mean is the average. Okay, and standard deviation represents a typical deviation from the mean. So it's like everybody is often that 5'5", 5'5" height, but then we might have some people that are on those tail ends with the 4'10" and the 6 foot people, and we want to know how many standard deviations they are from the mean. How much do those numbers deviate from that mean of, say, 5'5"? A low standard deviation indicates that the points tend to be very, very close to one another, close to the mean, actually. And a high standard deviation indicates that the points are spread out over a large range of values. For example, we've got 3 students that we're looking at their last 3 test scores as follows. So student A got all 80s. Student B had 60, 80, 100, and student C had 70, 80, 90. So the mean for each one is an 80. Remember, mean means average. And to find the average, you do x plus x plus x over, in this case, 3. So 80 plus 80 plus 80 over 3 gives us 80. 60 plus 80 plus 100 over 3 gives us 80, excuse me. So student A is consistent, meaning he will deviate little to none, in this case it's none, from the mean, because the mean, again, is 80. Student B has a very wide spread of scores, meaning he deviates quite a bit from the mean. He goes from 60 to 80 to 100. The mean is 80. Happens to be that he got a score of 80 as well, but he is 20 from the mean right here and 20 from the mean right here. So he deviates a lot, meaning his standard deviation is bigger than that of student C, who has a moderate spread, meaning he's moderately deviating from the mean. He's only 10 away from the mean and 10 away from the mean, and then, of course, that 80 is right on the mean. So student B would have the largest standard deviation because he deviates the most from the mean. All right, flip to the next page. So here we're looking at something called normal distribution. When we look at standardized tests such as Regents tests or the SATs, ACTs, most results fall in a normal distribution. They often look like this bell-shaped curve. If you can imagine a bell that a teacher might ring, wow, that's a horrible bell. I should probably find you a picture that looks better than that. All right, here we go. This is what I meant to draw you. So the bell-shaped curve looks like a bell because, if I can draw on it, we've got that shape going on where it comes up in the middle and then the tail ends. Okay, so bell-shaped curve is normal distribution. So in this particular case, we have a lot of people that are scoring between 60 and 90, for example, but very few that are on the tail ends of 10 and 140. So we can also talk about standard deviations on a normal curve as well. So on a normal curve, or that bell-shaped curve with normal distribution, we have the mean right in the middle. So the mean goes here, which is 0 standard deviations from the mean. SD, by the way, means standard deviation. And then we can go 1 standard deviation to the right and 1 standard deviation to the left. You will find 68% of your data in between 1 standard deviation from the mean. Okay, these numbers are going to be super critical for you to remember. So start memorizing them. 1 standard deviation, 68% of your data lies within that area. So that's this space here underneath the curve. Then if I go out 2 standard deviations, 1 to the right, 1 to the left, 1 additional, I should say. 2 standard deviations gives us 95% of the data. Okay, so that's including all of this area. 95% of our data is within 2 standard deviations from the mean. And then last but not least, we typically can go up to 3 standard deviations away. 3 standard deviations away gives us 99% of the data. That's a whole lot of data, but there's still that 1% that doesn't get accounted for within 3 standard deviations, because sometimes you might have an outlier that's out here close to 4 or 5 or 10 standard deviations away. Okay? So again, these numbers critical for you to memorize. And I'm going to maybe box them in or highlight them. and then how many standard deviations from the mean. Okay, so we're going to use this information and apply it on the next page. So it says, given the data set of scores on the math section of the SAT that follow the normal curve, the mean is 500 and it has a standard deviation of 100. So I'm going to put some scores right on this bell curve right here. So these 0, 1, -1 are standard deviations. 0 standard deviations, 1 standard deviation, 2 standard deviations, 3 standard deviations. Same thing on the left side. 1 standard deviation to the left, 2 standard deviations to the left, and 3 standard deviations to the left. We don't typically talk about it in negatives, except that the fact that the negative means we are below the mean. And again, the mean was 500. I never finished filling that part in. And so then if the standard deviation is 100, that means I add 100 to 500, giving me 600. Add 100 to 600, giving me 7. And we're just counting up by 100s, and then of course counting backwards by 100s. So again, 95% of the data lies within 2 standard deviations, 99% of the data lies within 3 standard deviations, and therefore 68% of the data lies within 1 standard deviation. So first I'm just going to remind myself 1 standard deviation above/below the mean before I answer this question. So I'm looking at 1 standard deviation below and 1 standard deviation above. What range of values contains 68% of the data? So within this region, 68% of the data would be between 400 and 600. Listen, I do not want you to write 400 to 600. This looks like you are trying to tell me that it's equal to -200. Okay, this is not okay. So again, put an and symbol, write the word to, do something besides a minus sign. Okay? So then I've got what range of values would contain 95% of the data? Well, recall that 95% of the data is within 2 standard deviations above and below the mean. This stuff in parentheses is just for us to help ourselves recall or remember how much or how many standard deviations 95% of the data is within. So now I've got to go out to 2 standard deviations. Boom, boom. So 95% of the data is within 2 standard deviations, landing me at the numbers 300 to 700. Okay, so answer here, answer here. Then the question is asked, what percentage of the data has a value of more than 500? So here's 500, smack dab on the mean. If I look to the right of this, so in this space here, how much data would lie to the right of my mean? Well, typically the mean is exactly in the middle. That's what a mean is, the average middle number. And therefore, you would have exactly half of your data, which is 50%. The next question says, what can we say about the score of 450 in this set of data? So I'm going to look to see where 450 would lie. It's about here. 450 is very close to the mean, and therefore we're going to say that it is likely to occur. So a score of 450 is likely to occur. And the reason we're saying likely to occur is because it's less than 1 standard deviation away. Now the true test here is that if it's likely to occur, it will be less than 2 standard deviations away. That's your test. It will be unlikely if it's more than 2 standard deviations away. And this is, of course, away from the mean. So likely to occur is less than 2, unlikely, or a rare occurrence is more than 2 away. So when we look at 700, for example, 700 lies right at that 2 standard deviations away. So a score of 700 is pretty unlikely. Unlikely to occur because it is 2 standard deviations from the mean. So again, 2 standard deviations is like your target. Less than 2 standard deviations on the right or the left, it is likely to occur. 2 or more standard deviations on the right or the left, it is unlikely or rare. So now we're going to talk about this thing called a z-score. Z-scores are going to be super important for you for the rest of this unit. Okay, a z-score represents the number of standard deviations. Let's define that again. Z-score is the number of standard deviations from the mean. So now I can look at this and I can say, oh, well, duh, 700 is 2 standard deviations from the mean. I can see that. It's very clear. But what if I asked you about the score 620? How many standard deviations from the mean? You'd say, well, it's between 1 and 2, but I want an exact number of standard deviations from the mean. So now we have this formula. I don't really care about 620. We'll care about other numbers in a minute. We have this formula for z-scores. So its value, meaning the given value in the problem, take away mean divided by standard deviation. So using the data from above, answer the following. How many standard deviations from the mean is a score of 400? So this is our value. They gave us to us in the problem. So the number of standard deviations means find your z-score. So we start with value minus mean, 400 minus that mean of 500 divided by the standard deviation, 100. So this is negative 100 over 100, which is just negative 1. So this is 1 standard deviation to the left of the mean. If I look back at my picture, guess what? 400, negative 1 standard deviations, meaning 1 standard deviation to the left of the mean. Okay? I'm just going to actually write that sentence for us off to the side. 400 is 1 standard deviation away from the mean to the left. That's just how we interpret that negative 1. Then the next question says, would a score of 520 be likely or unlikely? Well, the way we have to figure that out is to know how many standard deviations from the mean it is. To figure out the number of standard deviations, we just apply the z-score formula. So z equals value 520 minus mean 500 over standard deviation 100. So this is 20 over 100. This is 0.20. So this is 0.20 standard deviations from the mean. Remember your kicker here. If it's less than 2 standard deviations from the mean, which 0.20 is, less than 2, then this is likely to occur. Justify your response just means show your math. And we just did that. So 0.2 standard deviations from the mean means that it will be likely to occur because it's less than that 2 standard deviations that we're looking for. Then the next one says, would a score of 41 be likely or unlikely? I don't feel like that was supposed to actually say 41, but we'll go with it. So z equals value 41 minus mean 500 divided by standard deviation 100. So we have negative 459 over 100, which is negative 4.59 standard deviations from the mean. So again, if it's more than 2 away, whether it's on the right or the left, then it will be unlikely to occur. Okay? I don't think there's anything on the back page, so we are good to go at this point. But again, I just want to reiterate this fact, and if you want to write this huge on the next page, do it. Because you need to understand that a z-score is the number of standard deviations. If you need to write that set of letters out in full words, standard deviations from the mean, then please do it. Z-scores seem scary, but I promise you they're not, as long as you remember that they are the number of standard deviations from the mean. And you calculate it by value minus mean over standard deviation. Okay? Let us know if you have questions. Otherwise, get to all of your practice problems. Write your summary, check your answers, bring it to your teacher, and then take your CFU. Adios.